Alright guys, today we'll be working on the Chevy Silver, what was that? Oh, no, sorry guys, hang on. So today we'll be working on the Buick Lucerne and the fuel delivery systems, like the fuel injectors and the fuel pump. Alright, let's see if this thing will actually start. We're gonna need that jumper pack. Ah, there's your problem right there.
We're going to be needing that jumper pack a lot.
More worky. Perfect.
Here we are inside the Buick. We got the top on hooked up, and as you can see on the screen here, in blue we have the fuel pump relay command. So right now, the key on, engine off, it's off. Here's pulse width modulation on the injectors. This is just from the last time I had it running. And then in purple is short-term fuel trim. So see, when I start it, these two, well, this one you'll see your fuel trim immediately, or your pulse width modulation immediately. Short-term fuel trim you won't see immediately because it takes a second for it to close the loop. And then as soon as I start it, you'll see that command go on. So there's the fuel pump on. That's just chilling for a second, and then you're going to start seeing the purple data when it closes the loop. But you can see here the computer pulse width modulating the injectors. So there you can see the car close the loop. So now the short-term fuel trims are active. So here I just wanted to point out real quick the fuel pump and sender on the wiring diagram. You've got the motor here and then the level sensor here, which those are all in one connector, and that gets its power from the fuel pump relay up top and its fuse. And then over here with the fuel pump, like you saw, is the fuel tank pressure sensor. So back there you have these two connectors, one for this unit and one for the tank pressure sensor.
So to find the fuel pump in the Buick, first you're gonna come over here to the glove box and you'll find the trunk release switch. And we come back over here to the trunk and you can see the fuel pump is right there. It's fairly easy to get to.
We're in the car again, and if you look on the top on screen under active tests, you can command the actuation of the fuel pump. So the engine's off right now. So as soon as I press on, it'll run the fuel pump. So you might be able to hear that. I'll turn it on for just a second. So you can hear it goes commanded value on, and then in the back seat, the fuel pump is behind the seat, so maybe you can hear it. That's the fuel pump turning on and off. All right, on this Lucerne, the fuel pump relay is this one here in the back seat. You can tell that that's it because if we turn the fuel pump on, you hear it now. Well, you heard the relay click. If we pull this, now it no longer does it.
All right, so now we're gonna start the car with the fuel pump relay off. As you can see, it's off right now. And we're gonna start it right now. So as you can see, the engine does not start because the fuel pump isn't giving it any pressure. So there's no fuel getting into the cylinders and to the injectors.
So here in the engine bay, you can see fuel rails on this side and on that side there. So here's the fuel hose that comes up from the tank, from the pump, to this crossover tube, runs to this bank and that bank. And there is no, if you look along the rails, there is no pressure relief valve. That's because if we look at all data over here, it says the fuel system is a returnless on-demand design. The fuel pressure regulator is part of the fuel sender assembly. So the pump in the tank has a regulator on it. Also, while we're looking at the injectors on the engine, you can tell that it's port injected. Your rail is right here, and your injector goes right into the intake manifold right above the cylinder head here. So to drain the fuel system pressure, it says to take your fuel system, your fuel pressure gauge there, and install it onto that fitting, which is this little Schrader valve fitting here. Come on, focus. That on the fuel rail. And then that little gauge has a valve on the side of it that you drain off into a tank. So that's how you're supposed to do that. So let's see how we do that. Alright, so here's the diagram for the fuel injectors on this car. You can see that they're all there and they all run to the PCM. They are controlled through the PCM. And then this pink wire runs to that fuse over there, so they have power all the time.
Alright, so here we have our fuel injector connected to our ohm meter. So you can see it reads about 12 ohms, 11 ohms, which is a bit high, so that means it's not a peak and hold injector, and that's also within spec. So come over here to all data. Fuel injector resistance, 11 to 14 ohms. So that means our fuel injector is in spec.
Alright, so here, right here we got the meter hooked up to a piece of ground. And then we're pinned into the power on the fuel injector, which is hot in run or start. So the car is in run right now. And you want to be careful not to let this touch ground because this is positive battery voltage. If you look right here, 12 volts. Alright, so here we're wired in to measure voltage drop. We got positive to the battery positive for safety, and then we got ground over to the injector ground side, the control side. And what we're seeing is about 0.3 volts at idle, so can you rev it up? Hey, can you rev it? You see that voltage drop increase. You see that voltage drop increase as the pulse width gets wider as you get more injector on time where the injector has a good ground, where it closes the ground. Alright, so here on the Lucerne we're hooked up to ground and to the control side of one of the injectors, which is the ground side. And we get these nice lovely waveforms like you'd see with a traditional injector. And I'm already zoomed in on this. You can see right here, that's your battery voltage. Right here, it drops that down to ground. So that's the duration that the injector is held open. And then you have your voltage spike up to here about, well, let's see. Well, anyway, up to 70 or so volts. If you look over here at the data stream, you can see the pulse width. I've got short-term fuel up on there for kicks. But you can look at the pulse width, and the pulse width here, about 3.9, 4.0. So if he revs it a little bit, hey Miles, can you rev it a little bit? You can see the change in that pulse width is the duration that it's holding the injector open for. So at idle, that's like, and if we look over here, you can see when he was revving it, the pulse width goes way up, and then as he lets off, it drops down. Alright, if we actually zoom in way on it and measure the pulse width, my little ruler here, it's right at about 3.008, which if you look at that, does not correlate. Pulse width is not the same. So I think somehow it's measuring, well, let's see, all the way over to the far edge. I mean, that's about 3.8 right there. So it must be measuring the entire waveform, I'm not sure. About 3.7, 2.8.
Alright, so we have our pulse width data here on our picoscope. And then we also have our short-term fuel trim and our pulse width measurement on the scan tool right here. and we're gonna hit the car with some propane.
It's a little hard to see. If you're watching this from the advisory board, we need more scan tools.
All right, so you're gonna put some propane in the intake. So as you can see, the pulse width decreases, so it means less fuel is being distributed. And you can see the fuel trim going all the way down. So right now it's running lean, and the pulse width on the scan tool goes with that. All right, and then we'll watch it now he stopped putting propane in it, and we'll watch it increase.
Yeah. You can see that the pulse width correlates with this decrease in pulse width, and the short-term fuel trim kind of goes crazy. It went super lean to more than minus 12%, and now it goes back, it compensates way rich, so it's just running rich for a minute and then it'll cancel out.